today. Knock on wood. We'll see what happens. But we missed going through 5.07. I was trying to get there last time we met, which was Monday, but we just ran out of questions, or ran out of time. So we're just going to cover these last few slides, and we only have like 5 slides, I think, and we'll probably have covered this, so not too bad. Here is the formula for the law of sines. Interesting, Will. That's a good question. Yeah, because we have law of sines, law of cosines, but no, there is not a law of tangents. That would make sense, right? But I guess just we don't need it because I'll show you that flow chart. Let's go to here. So I'm kind of skipping ahead, but we'll come back and touch on this again in a second here. But really what you're going to have to be able to sort out for the Unit 5 test is the right tool for the job. So I file transferred this to you guys as a Word doc not this week, last week. Remember when I sent you guys like 10 documents in one class connect? It was that time. And this is one of the things that was on there. So we've learned all kinds of stuff. We've learned trig ratios. We have Pythagorean's theorem from, way back first semester. Now we have sine rule, cosine rule. So when do you use what? So here's how you sort that out. Is the triangle a right-angled triangle? Yes, go down this branch. No, go down this branch. And so this will help you sort out when to use which. But you'll notice is that we don't need a law of tangents, because really if you have trig, Pythagorean's theorem, sine rule, cosine rule, then you'll be able to find out any possible angles or sides just with those tools. So yeah, we don't need that. We have enough with what we already have. It's hard enough to sort that out, right? So we'll keep it to as little as possible. All right, so the law of sines. Here's what it says. Now notice the pattern. What do you guys notice here in the pattern for this equation? One thing here, you're only going to use 2 out of these 3 things. So you have sine A over A equals sine B over B equals sine C over C. You're not going to use all 3 of those. So you might just use, let me switch colors. You might just use this combination. You might use this combination, or you might use sine A and C together, okay? Yes, good. So exactly, you guys got the pattern. So it's always the sine of the angle over the side across from it, the corresponding side, right? So we've talked about this before. If you have a triangle, the capital letters are the way we name the angles of the triangle. And then the side that's opposite that angle, we use a lowercase letter, the same letter, to name the side. So that is the pattern here, and that will really allow you to memorize the law of sines, without making it too difficult. So just remember, you can pair any of these 2 together. So you can have 3 things, but you only need to use 2 of them. So it just depends on which 2 you need to solve for. Uh-oh, are we having tech issues? You guys are getting kicked out and back in, huh? That's not good. Okay, so down below here it says you can use the law of sines to solve the triangle if you are given these things here. Now, if you just think through the problem, you'll be able to get this, without memorizing. But this is just an extra tip. So if you have 2 angle measures and any side lengths, that would be a case where you could use the law of sines. Or if you need 2 side lengths and a non-included angle measure, then that would be another case where you'd use law of sines. Okay? All right, law of cosines. First let's read this up here. So the law of sines cannot be used to solve every triangle. Also, let me go back and talk about solving a triangle. When we talk about solving a triangle, what we mean is that we are going to find every single angle and every single side. So if you are asked to solve the triangle, that means you want to find angle ABC and you want to find side ABC. Okay, so all 3 angles and all 3 sides if you're asked to solve it. So the law of sines is awesome for some cases, but doesn't solve everything, so we also need law of cosines. Now the law of cosines looks really complicated, right? It's this big, long equation. And it definitely is more complicated than law of sines, especially if you're missing the angle. If you're missing one of these sides, it's not too bad, but you're definitely going to need to get your algebra skills. Okay, this is where if you're not great at algebra, law of cosines is going to be tricky. So yeah, it does. It kind of reminds you of Pythagorean theorem here. Yep. But I'll go through how to solve this, and then as always, practice makes perfect. So if you're kind of confused by this, once you do a few of them, the pattern to solve it is going to be the same as well. So even if you're kind of nervous about the algebra part, then you'll be, you know, if you practice enough, you'll see the pattern and you'll be fine. Okay? So let's just go down the flowchart again for sine rule and cosine rule. So you'll notice that the sine rule and the cosine rule are actually tools that we have if we do not have a right triangle. Okay? So if you have a right triangle, you're going to use either trig or Pythagorean theorem or a combination of both to help you solve the triangle, to find all the sides and all the angles. But sine and cosine, the law of sines, the law of cosines, that's used if you don't have a right triangle. Okay? So that's the first branch. And then to determine whether you're going to use the law of sines or the law of cosines to start with, ask yourself, do you know a side and its opposite angle? So like, for example, would you know angle B and side B? In that case, then yes, use the sine rule. Okay? If that's not the case, then no, use the cosine rule. Okay? So I have 3 problems we're just going to practice here to get used to how to use these equations and when would you use them. So we have triangle ABC, round the lengths to the nearest degrees. I love that math humor, Will. Yes. If you don't have a right triangle, you have a wrong triangle. All right, so we want to round the lengths to the nearest tenth and angle measures to the nearest degree. All right, so let's label the triangle. Let's see what we have here. We have angle B right here, that's 20 degrees. We have angle C right here, that's 31 degrees. And we have side B, which is 210. Okay, find A. Oh, and I should put 2 arcs there. Okay. Now in this case, it's just asking us to find A. We could, what would be the difference if it said solve? If it said solve the triangle, what would be our goal? What would we be going for? So if you say solve the triangle, what does that mean? Yes, or left triangle. There you go. So if it had said solve the triangle, you want to find all angles and all sides. Okay, so that's what solve means. Okay? In this case, we're going to get by with a little bit less work. We just want to find A, and that's it. So let's go back to the flow chart. Take a look at the picture. Okay, we know angle B, we know side B, we know angle C. Those are the 3 pieces they're giving us. And we could actually find angle A as well, right? Because you know that these 3 are going to add up to 180. So if we needed to, we could find that by adding these 2 together, subtracting from 180. But let's go back here, okay? So it's not a right triangle. We could figure that out. And we do know a side and its opposite angle, because we know angle B and we know side B. And so that's why we're going to use the sine rule for this first one. Okay, so we know angle B and we know the side across from it, side B. Okay, so let me write a note here. Use law of sines because we know angle B and we know side B. Okay, so that's the reasoning. Does that make sense? Do you guys see how we can tell which one to start with based off of that flow chart? Okay. Now we have to remember the law of sines. Now, like I said, the law of sines is easier. So what I would recommend is to start with the angle and the side that you know. So we know angle B and side B. So I definitely want to put sine B over B in my equation. What do you think the other one would, do I want sine C over C or sine A over A? It's kind of a trick question. Well, not trick, but tricky question. Yes, good, Tristan. Good, William. Why A? Because I know a lot of you, just admit it, give me a smiley face if you're thinking C. How many of you guys were thinking sine C over C because they gave us angle C? Okay, Sarah's honest. She's like, yes, I was. I know Sarah's not the only one. Okay, but it's not angle C over side C. Now, it wouldn't be, you would get information off that. You would be able to solve for side C if you did that, but you'd be doing extra work because we don't actually need side C in this case since we're not asked to solve the triangle. We just need side A. So I know probably the reason you guys are thinking, if you're thinking sine C over C, you're thinking, well, I have to do that because I don't know what angle A is, so I'm not going to be able to do sine A over A. So, oh, there you go, Tristan. See, that's smart. Okay, because remember, we're going to solve this using algebra, right? And we remember from algebra that you can only have one missing thing. So you're probably thinking, well, if I'm missing side A and angle A, I'm not going to be able to do that. But we actually do know angle A. How can we find angle A up here? We don't have it to start with, but we can find it. How can we find it? Good. Triangle sum theorem. Ooh, nice. I love that you put the name of it in there. Nice. Okay. Yes, and that is absolutely right, William. But in this case, or you can use a theorem that we know, right? So triangle sum theorem tells us if we add 31, 20, and angle A together, that should add up to 180. And then we can subtract 51 from 180. Excellent, guys. And that would give us that angle A is 129. Nice. So this angle right here we actually can solve for. And then when we plug everything in, watch what happens. We know angle B is 20. We know side B is 210. We know angle A is 129. And we're only missing one thing, which is side A. And now what we're going to do is we're going to put sine 20 in our calculator, and we're going to write that to 4 decimals, 3420 over 210. And we're going to put sine of 129 in our calculator and write that out to 4 decimals, 771 over side A. Yeah, definitely not trying to scale, right, Tristan? It should definitely be obtuse. Good point, good point. So yeah, this triangle definitely does not look accurate. Yeah, exactly. Good point. Good point. So that's the other misleading part, but go with the numbers. And then from here we're going to cross multiply. Okay, so we get A times 0.3420 equals 210 times 0.7771. And then we're solving for A, so we want to get rid of the decimal. So we divide by 0.3420 because that's going to cancel that out on the left side for us. So we're going to end up putting 210 times 0.7771 divided by 0.3420 in our calculator. And I got 477, and then if I round it to the nearest tenth, which is what the directions are asking us to do for a side length, it'd be 0.2. How about you guys? Did you get that? Let me know, because sometimes I mess up. Does that look right? Yeah. Yes. Well, I think it's because they're just using the same triangle and then they're changing the different amounts. So on the next screen, we actually have the same triangle, but then the information's different. Okay, so in this case, that would be side A. And we're done because that's what it's asking for. Okay, so notice, same triangle, but different information. This one maybe looks a little better. They have angle C is 110, so at least it's obtuse this time, right? Side A is 16, side B is 10, and we are looking for side C. That's what our goal is. All right, so take a look at what we have. We have two sides and an angle in between. So let's go back quickly to the flow chart. Okay, so it's not a right angled triangle. If you have an obtuse angle in there, so I know you guys might be saying, well, I don't know if it's a right triangle because I only know one angle, so how could I possibly know these two? But remember, if it's a right triangle, there's no way that the other two can be larger than 90 degrees. It can't be an obtuse triangle and be a right triangle at the same time. So because this is an obtuse triangle, that already rules out the fact that it's a right triangle. So no, don't use tangent, because notice where tangent, sine, cosine, and tangent are the SOHCAHTOA part. Okay, this is the SOHCAHTOA part. Don't use SOHCAHTOA unless it's a right triangle. Okay, I know it's a little confusing because we are calling this the law of sines and the law of cosines, and we're using sine and cosine in the equation, but it's a different setup. It's different than the trig ratios. So be careful there. Only use SOHCAHTOA if it's a right triangle. So it's not a right triangle, and we do not know a side and its opposite angle, so we're going to use law of cosines. Does that make sense to everybody, how to use the flowchart to figure out what tool to use? Good. Well, that works too, Ben. Yeah, exactly. So either way, however you need to remember it, that works. I don't know, Will. I have never heard of a law of tangent. I don't think there is one. If there is, I haven't used it in my my whole math career. But maybe you could discover something. Maybe there'd be a reason where you'd use that. I don't know. All right. So what I want you to pay attention to, because again, this looks confusing, right? But there's a pattern to it, okay? So if you're looking for a side, like we are in this case, we're looking for side C, then what you want to do is you want to use the formula where the side that you're looking for is over here on the left. So in this case, we want to use the last formula, where the side that we're looking for is the one over here on the left, okay? The other situation that you might encounter is you might be looking for an angle. If you're looking for an angle, then you're going to want to use the formula that has the angle you're looking for. So if we were looking for angle A, we'd want to use the first formula. If we were looking for angle B, here's angle B, so we'd have to use the second formula. So that's going to determine which formula you use, okay? Now in writing the formula, you'll notice there's a pattern. So we use side C. That means the other two sides are going to come first here in the formula. And then notice how the two sides that you already know, those are also repeated here. And then the angle that matches with the side over here is the angle that always is used. Okay, so you'll notice that here. If you use side B here, then it's side A and side C here, side A and side C here, and then the angle matches with the side. Okay? All right, good. So Tristan says he thinks it's 18.86, or we could round to 18.9. So let's check that. So let's plug things in. I'm going to move this. I can move this up just a little to give us some room. Okay, so we're going to have Let's see. I'm gonna cover up the triangle because we don't really need the triangle in order to complete the formula. Just so I don't run out of room, because I think I might. So I'm gonna have c squared, and then it's a squared that comes next. So I'd have 16 squared, and then b squared minus 2 times a times b times the cosine of c, and I know angle C is 110. Okay? Yes, good, Ben. So that's right. So the next part, this is where it gets a little tricky. Just be real careful here. You're using, please excuse my dear Aunt Sally. So we want to do 16 squared, 256, plus 100. Now, here what you can do this at the same time. You can either do the squared part and then multiply all this together, or you can also, it's okay to multiply this all together because you're going to end up doing that in the next step anyway. So take 2 times 16 times 10 times the cosine of 110. And you should be able to put that all into your calculator. Yes, that's very advanced. Okay. And if we do that, okay, let's see. Let me see, I think I'm in, let's see. No, I'm in degree mode. I got a negative number, is that right? Let's see, 2 times 16 times 10 times the cosine of 110. Yes. Oh, like for the final answer, is that what you're saying, Will? Gotcha. Okay. So at this point, though, when I multiply all that together, it's kind of strange. You get a negative number. Okay, so that is from, let me color code here. Hold on. So from this part, when I multiplied all that together, that's the decimal that I got. So that's where the negative 109.4464 is coming from. Now, remember, we have a double negative right here, which really means plus. So what I'm going to do at this point is I'm going to take 256, put that in my calculator, add 100 to it, and add 109.4464 to that. Okay, and I end up with 465.4464. Now I need C. Right now I have C squared. I need C. And so in order to do that, I square root that big number there. 21.57, so 21.6. And yes, since this is a side length, we would round to the nearest tenth. Okay, so we keep it at the 21.6. Okay, so see how the law of cosines, the geometry part, isn't as hard as the from here down algebra part, right? So knowing which formula to choose, that's the geometry part. After you plug everything in, or even when you start plugging everything in, that's algebra. So that's usually the part that will get students on the law of cosines. Okay, let's try one more, and then we're done. All right, we're not going to end at 11, huh? Okay, let's. I'm going to try to wind it down. I talked too much at the beginning, I think, because I was hoping we'd be done by 11. That's okay. All right, so notice here what we have are the three sides, okay? And we want to know angle A. So if you go back to that flow chart, in order to use law of sines to start with, you'd want to know an angle and the side opposite it. Well, we don't know an angle and a side opposite it. So that means we're going to use, yes, I am a chatterbox sometimes. We're going to use law of cosines, okay? Yeah, exactly. Well, we don't know any angles. But tell me, let me put this on the board here. Which formula do you think we'd want to use? Let me turn on the whiteboard privilege. You guys point to the formula. Which one do you think would make sense here? If we're looking for angle A, which formula? Yes, good. Good. The first one, because, yeah, where that smiley face is at, because that's the only one that has angle A in it. This formula has angle B, this formula has angle C, so those aren't going to help us, right? Excellent. Okay, so you have already accomplished the geometry part of this question. That part was easy, right? Now for the algebra part of this question, and that's going to get trickier. But if you follow the pattern, it will always be the same pattern to solve these, okay? So first thing we want to do is plug everything in. So we have A squared, so we'd have 20 squared, B squared, 15 squared, C squared would be 8.3 squared minus 2 times B times C times the cosine of A. Okay, everybody following how I plugged all of that in? Now solving this, it gets tricky. But the pattern's going to be the same. The first thing I want you guys to do is to do some multiplication. You're going to square the 20, square the 15, square the 8.3, and multiply these three together. So here's what it's going to look like. 20 squared, 400, 15 squared, 225, 8.3 squared, 68.89, okay, minus, now here's where it gets a little bit tricky. 2 times, yeah, I know, we don't want to do this, right, Ben? 2 times 15 times 8.3. So you're going to write that as 249. So when I did the 2 times 15 times the 8.3, I got 249, okay? And then you're going to write the cosine of A next to that. And if you want to put parentheses around the cosine of A, you can do that as well, just to kind of keep your work organized. Okay, so here's where it gets probably really the hardest part. Okay, so be really just careful here. We do need to find A, yes, and we're getting there. So what you're going to do is you want to get, in order to find A, we have to get A by itself, right? Right now it is definitely not by itself. There's lots of stuff over there on the right side of the equation with it. So what we're going to do is we're going to subtract 225, and we're going to subtract 68.89 on both sides. Okay, so 400 minus 225 minus 68.89. I'm going to write my work over here on the right because I'm running out of room. But on the left-hand side of the equation, you should have 106.11. And on the right side, what's happened is that these have canceled out. Now be careful. We have a negative sign left and 249 times cosine of A. So that's what we're going to transfer over here to the right. Negative 249 times the cosine of A. How are you guys feeling about that step? I'm going to pause and see if there's questions. Does it make sense to you guys how we found, we squared the 20, the 15, the 8.3. We multiplied these three numbers together to get the 249 right here. You could ask some good questions. So if you wanted to, you can add the 225 and the 68.89 together first and subtract that sum from the 400. That would also be just fine. So if you're more comfortable adding the first two numbers together, you can do that. The reason that we're waiting on the 249 is that it is connected to the cosine of A by multiplication. These two numbers at the beginning are just constants. They're just numbers, and they're like terms. We can add them together. This one isn't a like term because it has the cosine of A attached to it. Okay? Yes, Tristan, that's true. Yes, you should get 106.11 either way. Just depends on what you're more comfortable with. Okay? Yes. Okay, now, again, we're trying to get the A dug out of that hole. Okay? So what we want to do is just make sure we follow, reverse order of operations in the right order. That's the challenge, is remembering your algebra skills. So the next thing to do is to divide by the negative 249. Like I said, once you practice enough of these, the pattern is going to always be the same. So if you're missing an angle, you're always going to go through the steps in the same order. Okay? Yes, so I'm going to divide by negative 249. And I end up with negative 0.4261. And remember, with sine, cosine, tangent, if any of that's in your problem, keep 4 decimals till the very final answer. Okay? And what's going to happen is the negative 249s are going to cancel out. And I have cosine A on the right. I have negative 0.4261 on the left. Cool, kind of, Tristan. We don't divide by cosine. How do we cancel the cosine out? What is the opposite of cosine? Like multiplication and division are opposites. What's the opposite of cosine? Yeah, it's called cosine inverse, but yeah, it's the cosine with a little -1. It looks like a little -1 exponent. That's how we're going to undo the cosine. So in your calculator, most likely you're going to have to hit like the second key, because cosine inverse is usually in a different color, and you're going to do negative 0.4261, and you should end up with 115.22, and then over on the right, these have canceled, and we just have angle A, which is what we're going for, so we're done. Okay? And since it says if we're doing angle measures, round to the nearest degree, we would just round that to the nearest whole number, which would be 115. So A equals 115 degrees. That would be our final answer here. Okay? And again, the picture's not drawn to look like that, but according to the numbers, that's what we have. Yes.